In the last video, we created our first Python script, datasetup.py, to create our training and testing data loader, as well as return a list of the class names that we're working with. But let's not stop there. Let's now see if we can turn our making a model code into a Python script. Now, this is the same model we used in Notebook 04. We've seen this before, so I'm not going to spend too much time as coding the model. I just want to focus on how we could turn it into a Python script. So if you want a step through of it, we have model 0 tinyVGG. This is where we created it in the previous section. But let's see what happens if we run this cell. Then if we run this one, creates an instance of our model. We've got a forward method. If we wanted to leverage the benefits of operator fusion, that'll be contained in that post that I showed before, how to make your deep learning models go brr. You could use that. Then we have device agnostic code. Then we do a dummy forward pass to make sure that the model works. And it looks like it does. So let's see how we can turn this modeling code into a Python script. So we'll come down here to the end of section 3, and I'm going to create a little text cell. And rather than rewrite all of our modeling code, so let's go call this making a model tinyVGG with a script, and we'll call this one modelbuilder.py. You can call it whatever you want. Sometimes you just see it saved as model.py. I'm going to call mine modelbuilder.py. And let's turn our model building code into a Python script we can import. So that's what we want to do. We want to be able to import our model from a Python script. So how do you think we could do that? Well, previously we wrote some code to turn our data setup using a magic function. So you might have already given this a go yourself. So we're going to write file, going modular, and I'm going to save it as modelbuilder.py. So that's going to turn whatever is in this cell into modelbuilder.py. So if we just print, hello, I'm about to build a model in here. Let's see what happens. Beautiful. Then if we have modelbuilder.py, there we go. Beautiful. Now, what if we just ran a Python? This is a Python program. So if we just go Python, going modular, modelbuilder.py, there we go. It does whatever's in that script. So ideally, we want to end up later on with train.py and it trains a model. But let's cover that later. We're up to here. So I'm going to put this into a string here. So this contains PyTorch model code to instantiate a tiny VGG model from the CNN Explainer website, just as we've seen before in previous sections. So we're going to cheat a little bit with this one. Rather than rewrite all of our modeling code, let's just copy what's in this cell above here. I'll show you how quickly we can turn this into a Python script. So we import torch, from torch import nn, then we just have our class tinyVGG with a doc string here. We come down and we're just going to copy that there. Now, do you think that's enough? Well, let's find out, hey? So if we overwrite, going modular, modelbuilder.py, look what we have in there. Contains PyTorch model code to instantiate a tinyVGG model from the CNN Explainer website. And there's all of our modeling code. So how about we try to create a model and we replicate what we've got up above here. We've got a single forward pass, but this time we want to leverage our modelbuilder.py script instead of our cell up here. So we have to replicate something like this. Let's see what this looks like. We'll go import torch. What we're trying to do is a dummy forward pass with the model that we create from modelbuilder.py, just to make sure that it works. So from going modular, import model builder. So this is going to import the model builder script that we just created. And then we can set up device agnostic code. We don't have to do this again, but I'm just going to do it anyway for completeness. if .torch.CUDA is available, else CPU. Beautiful. Now let's instantiate a model from the model builder.py script. We can do this how? Well, let's find out, hey? Torch manual seed. We want to go model1 equals, instead of just writing plain tiny VGG, we can go model builder dot tiny VGG. And then if we look up, can we look up the doc string here? Oh, we haven't imported this yet. So if we just run that, dot tiny VGG, there we go, look at that. Creates the tiny VGG architecture, replicates the tiny VGG architecture from the CNN Explainer website. Here's our args, input shape, hidden units, output shape. Where do we get this from? That's the doc string that's in here. Class tiny VGG. That's all I've done. I've written the doc string here in the style of Google docstring, Google Python docstring. All right, let's keep pushing forward. This is so exciting. Look how quickly we can create a model now. Hidden units, let's just stick with 10 like we've been using in previous sections. Then the output shape equals length of class names. And then we're going to send this to the target device. And then let's have a look at model 1. Do I have enough brackets there? I think I might need one more. Oh no, that's correct number of brackets. Let's run that. We get a tiny VGG model from our going modular script, model builder. How good is that? Now let's try a dummy forward pass. I'm just going to copy the code from up here just to make sure it works with the exact same code. This is a dummy forward pass here. We've seen what this looks like. All we do is we get a batch of images and we get a single image from the batch and unsqueeze it so that the single image fits the model, the shape fits its model. We want to perform a forward pass on a single image, but instead of model 0 that we created from within the notebook, we want to use model 1, which we created. We still created it from within the notebook, but we used the code from modelbuilder.py. So let's just make sure it works. And yes, it does. Woohoo! Look at us go. We are slowly but surely turning in, well, not even slowly, we're going quite fast. We are turning our useful notebook code into Python scripts. So do you remember how long it took us to first write this model? And we've written it a few times now, but now we've got it saved in modelbuilder.py. So we could just import this script and we have a tiny VGG model ready to go. And of course, you could use modelbuilder.py for any of your PyTorch models and use similar PyTorch code that we've written here, or Python code, to import it and instantiate it ready to go. This is the power of going modular. But we started with a notebook, and we practiced writing functions like train step, test step, and train to see if they worked. And we used the notebook to experiment. This is my workflow. What I do day to day as a machine learning engineer is I try things out in a notebook, and once they start to work, I save them to Python scripts so that I can use my useful code over and over and over again. So let's keep pushing forward. You might want to try it yourself. We've got train step, test step, functions, and train. These are all from Notebook 4, nothing different here. All I've done is I've added a doc string to each of them. You might want to practice writing these using Google's Python functions and methods style guide, as we've discussed before. Let's turn these 3 functions in the next video into a Python script called engine.py, because that's what drives our model training, right? These 3 functions. So let's call the script something relatable, engine.py. I'll see you in the next video.